So far, when describing transformations, we were literal about the description about each transformation, whether it's a translation, a reflection, a rotation, or a dilation. So today I wanted to go over the algebraic way of writing a transformation. So the first way you were taught to do a translation was something like go right 6 and down 7. The correct algebraic way of writing that is take every point of the preimage xy and transform it so that every x coordinate is going to get added 6 because you're going to the right, and every y coordinate is going to get subtracted 7 because you're going down 7. So this right here that I'm underlining is the correct way of writing the algebraic way of a transformation, in this case a translation. So this coordinates right here stands for every point of the preimage. This arrow right here stands for the transformation. And this right here represents the translation of going 6 units to the right and 7 units down. So one of the things you need to understand is for translation, x goes in the left or right direction. So going right is plus, going left is minus. And in the same case, which I'm not going to write down because I ran out of room, the y is on the up and down direction. So going up would be plus, and going down, like this one, the y minus 7 is going is minus. So let's take this example one of a translation and let's apply it. So the preimage of triangle A, B, and C is right there in that fourth quadrant, all right, where A is at 2, -3, 4, and B is at 4, -1, C is at 5, -5. If we took this translation of taking every point xy and transforming it right there, transforming it to 7 units, x minus 7 and y plus 2, this right here, x minus 7 means go left 7. This right here means to go up 2. So we just translated that x minus 7 to left 7 and y plus 2 to up 2. We just take every point and just apply what you guys already learned. So you go right 1, 2, 3, 4, 5, 6, 7, and then go up 2, 1, 2. So right there is going to be my A prime. Alright? Same thing with this one. The B, 1, 2, 3, 4, 5, 6, 7, and then go up 2, 1, 2. So right there is my B prime. C is the same thing. 1, 2, 3, 4, 5, 6, 7. Then go up 2, 1, 2. Right there is my C prime. And if we connect all of those vertices together, you end up getting this transformation. Hopefully I got those lines correct. Of x minus 7 and y plus 2. Alright? But another way to do it is just doing it algebraically. If you took every, oops, let me do that again. If you took every point let's take example here, A, and you just applied it. Here, A, x is 2. So 2 minus 7, 2 minus 7 ends up being negative 5. So your x-coordinate for A prime should be negative 5. Alright, and then the y, you got negative 3. So negative 3, and it says here plus 2, negative 3 plus 2 ends up being negative 1. So your coordinate should be at negative 5, negative 1. So let's see if that's correct. So coordinates should be negative 5, negative 1. This is my A prime right here. Let's check. That is going to be 1, 2, 3, 4, 5, negative 5. And then down 1, that's negative 1. So yeah, that's correct. So if you applied 4 minus 7, that's going to be negative 3. Negative 2 plus 1 is going to be positive 1. So B prime should be at 3, 1, which it is. B prime is 3, 1. If you took C, 5 minus 7 is negative 2. Right here, this is negative 2. And negative 5 plus 2, negative 5 plus 2 should be negative 3. And this is 3 down, so that is correct too. So just applying the algebraic transformation to every point, or at least the vertices of this pre-image, you end up getting the coordinates of the image for A prime, B prime, and C prime. Same is true for reflection. There are two types that we're reflecting, alright? There's other ways of reflecting over other lines in the coordinate plane, but we're going over the basics. So we're reflecting only over the x-axis and only over the y-axis. When you reflect over the x-axis, you are taking every point, x, y, every coordinate on that pre-image, and transforming it. In this case, it's a reflection where all the x's stay the same, but all the y's become the opposite of whatever it is. So that's why we put down negative y. So again, over the x-axis, the x's stay the same, the y's become opposites. Over the y-axis, all the points, alright, that we get reflected over the y-axis, the x's change. It becomes the opposite of whatever the x value is, but the y's stay the same. Alright? So the best way to see that is actually to do an example.